Remember from the introduction of this course, we went over an example of how reinforcing bar or rebar calculations can quickly become highly skewed. We're going to revisit this concept from a technical perspective. And in the lecture above, Jay already discussed how to read the bill of materials on the construction drawings and notes that you will need two sets of materials, one for each tower, the same, of course, for the anchors. And Jay also notes that you need to size your bar order appropriately for efficient cutting. This is true. However, the reality of the situation is that when you order them, bars will come in standard lengths. Generally speaking, that is 6 meters in Eswatini and 12 meters in Bolivia. So let's use the 12-meter bar as an example. There are multiple ways in which we can create waste here, so it's important to consult your in-country manager ultimately on your final numbers. But first, in order to transport this bar into trucks, let's say, as we did before, it's bent into a U shape, and rebar is structural and cannot be unbent. So some is lost in the U shape at the end of the bar. Let's imagine that it forms a semicircle diameter with a diameter of 20 centimeters, and that arc semicircle perimeter is 50 centimeters. So now we lose 50 centimeters off our bar, and we have some 5 3/4 centimeter bar length left over if it is done perfectly symmetrical on either side. Now, if we need a 413 centimeter cut, sorry, that would be meters back here. A 413 centimeter cut, we have a certain amount of waste. So in order to do this most efficiently, it's good to drop a cut sheet for all of your rebars calculations in your tower and anchor suspenders, and try to make the cuts the most efficient as possible. However, be careful, because the most efficient cutting scheme would then need to be followed in country, because if you order for the most efficient scheme, there is potential for running out of material if that's not actually followed. So another way I like to do this more from an automation point of view is calculating a loss factor. This is something I like to use so that the QTO can remain accurate as I customize my abutment. And of course, at the end, I'll go back and check to make sure that everything has been calculated correctly. But the way I like to calculate loss factor is essentially the amount of meters of ordered bar length you need to get a meter of desired bar length. So for example, the loss factor of a A03 bar under the following conditions is 0.75. So for every 1 meter of ordered bar length, I actually only get 3/4 of a meter of usable bar length for an A03 rebar bend. So I then divide the total length of bar necessary, the final column in the bill of materials, by the loss factor to get the inflated amount of bar needed that then needs to be ordered in order to have the right amount of rebar bent. This method, however, is not 100% foolproof, because it relies on governing assumptions about the construction practices and doesn't account for ingenuity in using leftover bar sections for other cuts. So therefore, I still use empirical data provided by the in-country managers to back calculate a loss factor for the rebar lengths that don't seem to match up with those spreadsheets. So for example, I use some hard-coded loss factors for A01, A02, and T01 bars. And the following problem, we'll explore actually calculating a loss factor and how you can use this.